So I'm a marine biologist working on reef-building corals, and I work on understanding how reef-building corals work as symbioses between an animal and the tiny dinoflagellate algal plants that live inside them that people often call zooxanthellae. And specifically what I've been working on is how we've begun to recognize over the last decade or more just how different the types of zooxanthellae that are found inside reef-building corals actually are. You might consider these things to have the same amount of genetic divergence as, say, the order of mammals has. Mammals is an order the same way these different orders of dinoflagellates are different orders. So you can sort of think of these zooxanthellae as being sheep and pigs and horses and cattle and goats. That's sort of how different they are. Basically what I've been doing is using genetics to differentiate and survey different types of zooxanthellae found in corals all over the world and trying to relate these distributions that have been popping out with environmental conditions. And what has been shown over the last 10 years is that many species of corals are able to host multiple types of zooxanthellae, and that in fact you can often correlate the kind of zooxanthella that a coral has with its environment. So there are, if you like, high-light, sun-loving zooxanthellae that you find in shallow waters on the reef, and there are low-light, shade-tolerant types of zooxanthellae that live deeper down. And you can even find colonies that are landscapes, so colonies that are, say, at intermediate depths on a reef where you find both types or multiple types, sometimes more than two, and the colony can be seen as a landscape over which these different populations of algae are constantly competing and coexisting for space. And it's a very dynamic relationship. As environments change, the particular composition of these algal populations also changes.